The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, good morning. We're going on to chapter 9 today. And we're going to be taking a look at section 9.1, which deals with radical expressions and radical functions, radicals such as square roots, cube roots, fourth roots, etc. So let's get started. All righty. Now, if you take, let's say, the number 3 and you square it, you get 9. If you take the square root of 9, you get back to 3. What does it mean if I were to ask you, tell me about your roots? Anybody? Tell me about your roots. What am I asking for? Anybody? You seeing it?
Ethnicity?
What's that?
Ethnicity?
Okay, sure. And like where you began, your beginning. So, but
Yes.
what you're saying, yes, okay. So if we take a number and we square it, and then we take its square root, we're saying, let's go back to its beginning before it was squared. What's the root that was squared? So it takes us back the other direction. So a square root undoes a square. They're sort of inverse operations. Is that making any sense? I hope. So let's say we've got 4 squared. Well, that's 4 times 4, which is 16. But the square root of 16 takes us back to 4. Now, 4 squared equals 16, but -4, the quantity squared, also equals 16. However, when we take the square root of 16, we just get what is called the principal square root. Likewise, if on your calculator you take the square root of 16, you only get the positive root, okay? So even though -4, the quantity squared is 16, when we take the square root of 16, we just get 4, which is the positive or principal square root. All right, any questions about that? Okay. Let's say we have the square root of 49. So we're looking for the number such that when we square that number, we get 49. So what positive number squared is 49? 7. So the square root of 49 is 7. Now, what if we have this kind of notation? We have the square root of 64, but there's a negative or a minus sign outside of the radical. Well, this symbol, this radical symbol, is a grouping symbol. So that means we do what's inside and then bring that outside, so the negative sign would hit it after we take the square root. Okay, now let's talk about some vocabulary. If I have the square root of 64, this thing is called the radical, and the quantity inside the radical is called the radicand. So that's kind of a strange word there, but so the radicand is everything that's inside of the radical. Okay, now let's say we've got the cube root of 8. So we're looking for some number such that it times itself, or that number cubed is 8. So what times itself is 8? 2. 2 times 2 times 2, or 2 cubed is 8. So the cube root of 8 is 2. Now, again, this is the radicand inside. This is the radical. This number out here is called the index. The index tells us what root we are taking. Now, when I write the square root of 64, I don't bother to put the 2 index there because math people often use shortcut notation. Since the square root is the most common root taken, they said, okay, if there's no index, that means that the index is an implied 2. All right, but if we're going to take any root besides a square root or a second root, we need to label, we need to put the index in there. So be careful of that. All right. Let's see. How about this one? The square root of 0.25. Well, what times itself is 0.25? 5 times 5 is 25. 0.5 times 0.5 is what? 0.25. Notice we got an answer that was larger than our original problem. Well, consider this. What's the square root of 1/4? That's 1/2, because 1/2 times 1/2 is 1/4, and 1/2 is bigger than 1/4, right? So when we're taking the square root of a fraction, of a proper fraction, a number between 0 and 1, the answer is actually going to be larger. Kind of strange, huh? All right, let's do some stuff. Wait, not yet, not yet. We're going to do some stuff on the calculator, but in just a minute. What's the square root of 81? Oh, go ahead. Sorry. Yes.
So when you're doing it like the square root, you can just divide the number by 2 and get the answer.
No. Okay. Now, and I understand what you're saying, because like, for instance, the square root of 4 is 2, and 4 divided by 2 is 2. So it appears to work there. But what's the square root of 9?
3.
So it's not 9 divided by 2, is it?
No.
Okay, so yeah, it happened to work in that case, coincidence, but yeah, not in general. Okay, good question though. All right, let's go back here. The square root of 81 is 9. What's the square root of negative 81? Well, it can't be 9 because 9 times 9 is 81. It can't be negative 9 because negative 9 times negative 9 is 81. There is no real solution, okay? The square root of a negative number is not real. You can't take the square root of a negative number and get a real answer. In fact, you can't take an even root. So square root, 4th root, 6th root, 8th root, you can't take an even root of a negative number and get a real answer, okay? That's an important rule. It's going to keep coming back to haunt us, okay? You can't take an even root of a negative number. Also, in fact, let's go back to this whole idea of the principal square root. Let's see, where was that? It's further down. Where did it go? There. When you take an even root, you can't get a negative answer either. So this principal, the principal root kind of idea. Okay, so with even roots, you can't take an even root of a negative number. And with even roots, when you take an even root of a positive number or 0, you can't get a negative answer. So there's these restrictions, but they have to do with even roots, okay? With an odd root, it's okay. So for instance, I can take the cube root of 8 and get 2, but the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. So you can take an odd root of a negative number, and you can take an odd root and get a negative answer. It's the even roots that have the restrictions. One more time. You can't take an even root of a negative number and get a real answer. And when you take an even root of a non-negative number, you can't get a negative answer, okay? All right, enough about being negative. So Let's see here. We're going to do this on the calculator, the square root of 340. So on a scientific calculator, quite often the square root key is a second function key. For instance, on my calculator, over on the left column here, there is a button that says x squared, and the second function key looks like that. Okay, so that's a square root button. So let's say I want the square root of 340. I'm going to push, first I'm going to turn the calculator on, then I'm going to push the second function key, and then when I push that x squared button, it actually activates the square root button. Okay, and when that comes up on my calculator, there's a left-hand parentheses. So then I'm going to put in 340. I'm going to close up that parentheses and push equals. And we're going to find this answer to 4 decimal places. So that's 18.439088891. To 4 decimal places, that would be right there. This 8 is going to round up. So I'm going to have 18.4391 is going to be my answer rounded to 4 decimal places. All right. Now be careful because, and again, you may have a different calculator, but right above the x squared button, which then has the second function key of the square root, there's a little caret key that we call it, which is a power button. And the second function of it is this root, the xth root, okay? So for this, you're going to use this when you're going to take cube roots, fourth roots, fifth roots. In fact, let's use that right now. And here's what we're going to do. We want the cube root of 8. Now, we already know the answer is 2, hopefully from before. But on my calculator, to get that, first of all, I'm going to push the second function key. Okay. Then I'm going to push this button, which has a second function key of the xth root. Okay. And that doesn't work. It says answer xth root. So what do I have to do? It's a little bit different here. I'm going to push the second function key. Okay. Now, I have to tell the calculator what index I'm going to use before I access this button. So in fact, even before I push the second key. So I'm going to start out by going 3. Okay. Then the second key. Then the this key, which then accesses this. So right now my calculator is giving me that. Okay, now it looks like it's 3 times something, but in this context, that 3 is the index. Now I'm going to put in an 8 and push enter, and I get a 2. So let me go back over that again because I'm probably confused you. When you're using the square root button, it's just second function, and then you access the square root button, you put your number in and you close it up and push equals. If you're using the xth root button, you have to put the index in as the first step, okay? Let's say I want the 4th root of 16, which is also going to be 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So on the calculator, I start out with the number 4. Then I push second, and then I push the little caret key, which gives me that. So I'm taking the 4th root of, and then I put in the 16 and push equals. Okay, so 4 second at 16 equals, and I get a 2. All right. Now, this button, at least on my calculator, doesn't give me a parenthesis, so I don't need to close it up. Okay. You may have a different calculator. If you have any questions about that, please let me know. I'll be happy to look at it with you and figure out how your calculator works. But most scientific calculators, I think, kind of have these same buttons, this xth root. But again, don't use that when you mean to use that. Okay. Let's see here. All right, now this says simplify each expression. Assume that all variables are unrestricted and use absolute value symbols when necessary. Okay. Assume all variables are unrestricted. What does that mean? Well, for instance, let's take the square root of x squared, all right? By saying that the variable is unrestricted, that means that x can equal any real number, okay? Now, if I say the square root of x squared is x, I may have violated one of the rules, and here's why, okay? If x can be any real number, then this could be a negative number. But I said a little while ago that one of the rules was when you take an even root, in this case a square root, you can't get a negative answer. So how are we going to fix this? By using absolute value bars, okay? So that means that whether x is positive or negative or 0, by taking its absolute value, we are assured it's not negative, therefore we didn't break the rules, kind of thing. This is a little bit tricky. You might get a small headache. Hang in there. You'll survive. All right, now. Again, these next examples, the variables are unrestricted. Okay, so they can be positive or negative. What about the square root of 4x squared? Well, the square root of 4 is 2, right? The square root of x squared is x. However, I don't know whether x is positive or negative, so I have to put absolute value bars around the x to make sure that the answer 2x is not negative. How are we doing? All right. How about this? The square root of 81h to the 4th power. What would that be? What's the square root of 81? What times what is 81? 9. Okay. What's the square root of h to the 4th? What times itself is h to the 4th? H squared. Because h squared times h squared is h to the 4th power. So the square root of h, the square root of h to the 4th power is h squared. Now the big question though, do I need absolute value bars on the h squared like I did on the previous problem with the x? And the answer is no, because even if h is negative, h squared would be positive, wouldn't it? So there's no way that that can be a negative number. So I don't need absolute value bars on the h squared. I know, it's kind of tricky. How about this one? The square root of 36s to the 6th power. The square root of 36 is 6. The square root of s to the 6th would be s to the 3rd, because s to the 3rd times s to the 3rd is s to the 6th. So the square root of s to the 6th is s to the 3rd. What about here? Do I need absolute value bars here? The answer is yes, because if s is negative, a negative times a negative times a negative, that is s cubed, would be negative. And I've got to have absolute value bars there to make sure that it's not negative. One more. How about the square root of 144 m to the 8th power? Well, the square root of 144 is 12. The square root of m to the 8th power is m to the 4th power. Do I need absolute value bars on m to the fourth power? No, I don't, because if m is negative, raising a negative number to a fourth power, to an even power, you're going to get a positive answer. Okay, so I don't need absolute value bars there. What about this one? What about the cube root of 8x cubed? Well, that would be 2x. Do I need absolute value bars here? No, because with an odd root, I can have a negative answer. That's all right. So it goes back to those two rules. I'm going to repeat them again. You can't take an even root of a negative number and get a real answer. When you do take an even root of a positive number or 0, you can't get a negative answer. Okay, so let's do this. Okay, if this is even, this can't be negative, and this can't be negative. When you're taking an even root, the radicand can't be negative, and the answer can't be negative. Okay, if it's an odd root, anything goes. Even root, no negatives inside, no negatives outside. All right, and I know you're getting tired of hearing me say that, but those two rules play a vital part, or play a vital part in this chapter. Okay, let's see here. What we're going to do now is I'm going to switch to another screen, and hopefully this will work well. We'll see what happens. So hang on a second here. I tested this earlier and it was working then, but sometimes it has issues. So we'll see what happens. Okay. Let's see. When I tried that, everybody disappeared. So let's try that again. Here we go. There we go. All right. Can you see on the screen, it looks like a piece of graph paper, and there's a graph over on the right-hand side. Just somebody confirm that if that's true.
Yes.
Thank you. Okay. Just want to make sure I pushed all the right buttons and everything. Okay. So now we have the following problem. It says complete the table and then graph the function. And then it says give the domain and range. All right. And the function is f of x equals the square root of x. Okay. Now, these table values are already given. Okay. 0, 1, 4, 9, and 16. So what we're going to do is we're going to take the x value. So basically we're going to find what f of 0 would be the square root of 0, which is 0. Okay. F of 1 is the square root of 1, which is 1. F of 4 is the square root of 4, which is 2. Are you following what I'm doing okay? Anybody have any questions about how I'm getting those numbers? Okay. F of 9 is the square root of 9, which is 3. And f of 16 is the square root of 16, which is 4. Now, notice they deliberately, because as I said earlier, the x values were already given in this problem. They deliberately chose x values that were perfect squares, numbers with two identical factors, so that when you took the square root of it, you got nice whole number answers. Okay. Now, for instance, I could have said, let's let x equal 2. Okay. And then I would have said, well, the square root of 2, and I'd go to my calculator and I'd go, let's see here, the square root of 2, and I get 1.4142135, and then I have to graph that awful thing. So by planning ahead, because we were going to take a square root, by putting a number that's a perfect square inside of there, when we took the square root, we got nice answers. Okay, so we can graph those nice answers. 0, 0, 1, 1, 4, 2, let's see, 9, 3, and 10, 16 is off the graph here, so we're going to get that. Okay. Any questions about that graph? Now, notice that it starts here and it continues on. In other words, 16 I could have used, used 25 and 36, et cetera, et cetera. So the domain starts at 0 and goes to infinity. The x values start at 0. In other words, I can put 0 or anything larger inside the radical and get a real answer. So there's my domain. The range, well, let's see. The range from negative infinity going up, the first range value is 0. And as this is going over, it's also going up. So the range is also 0. This should be a bracket, 0 to infinity. Any questions about that example? All right, let's take a look at another example. Same directions, complete the table and then graph the function. And here we have f of x equals the square root of x plus 2. And we have the same inputs. Why do we have the same inputs? Even though there's a plus 2 as part of this function, the plus 2 is outside of the radical. It's after we take the square root. So this compared to this, we're going to get the same numbers here, but then we're going to add 2 because we're going to take the square root and then add 2. Okay, so watch how that happens. So f of 0 is the square root of 0 plus 2, which is 0 plus 2, which is 2. The square root of 1, or excuse me, f of 1 is the square root of 1 plus 2. Well, the square root of 1 is 1, and 1 plus 2 is 3. F of 4 is the square root of 4 plus 2, which is 2 plus 2, which is 4. The square root, or f of 9, is the square root of 9 plus 2, which is 3 plus 2, which is 5. And f of 16 is the square root of 16 plus 2, which is 4 plus 2, which is 6. So if we compare these values with these values here, okay, these new values are all 2 more. We put a number in, took its square root, and then added 2. So what does this graph look like? Let's see. 0, 2, 1, 3, 4, 4, 9, 5. Okay, so how does that graph compare to that one? It's up 2 units, isn't it? Because it's been raised 2 units. So now what's the domain? Well, the domain is still 0 to infinity. But what's the range? The range would go from 2 to infinity. Okay, we still got the same input values, but the outputs, the range, the lowest range value is 2, and then it goes up from there. Any questions about that? Okay. Let's see here. Let's go to this one. And let's take a look at a couple of things here. F of x equals the square root of x. We did this earlier, and I want to put this back up here. X, y, 0, 1, 4, and 9. And this was 0, 1, 2, and 3. Okay. And that graph 0, 0, 1, 1, 4, 2, 9, 3. Okay. So this is one that we did just a little while ago. Okay, back here. All right. But now, next to it, I'm going to put, let's go g of x equals the square root of x, and we're going to go minus 2. But the minus 2 is inside the radical. Okay. Now, my goal is to get nice output numbers. Okay. Let me show you what'll happen if I just use the same inputs. Okay, so let's just go with the same inputs for starters. All right, g of 0 is going to be what? The square root of 0 minus 2, which is the square root of negative 2, which is not real, so I can't do that. G of 1 is going to be the square root of 1 minus 2, which is the square root of negative 1, which is not real. I can't do that. G of 4 is going to be the square root of 4 minus 2, all right, which is the square root of 2, which is 1.414, blah, blah, blah. Not nice. And g of 9 would be the square root of 9 minus 2, which is the square root of 7. Oh, man, what's the square root of 7? Let's see here. Square root of 7 is 2.6457, blah, blah, blah. Okay. My point being, because of this change inside, using the same inputs doesn't give me nice results. Okay, so let's go back and let's see if we can figure out what to use to get nice results. What did I have? X minus 2, I think it was. Yeah. All right. Think about what happens, okay? Let's just say that right here I have star. G of star is going to equal star minus 2, right? So whatever I put in for x, I'm going to subtract 2 from it before I take the square root. So it seems to me like I want to start out with a number that's 2 more than these. So then when I put it into the radical and I subtract 2, it'll be as if I'm putting these numbers in and I'll get nice results. Let me show you what I mean. Okay, 0 plus 2 is 2. 1 plus 2 is 3. 4 plus 2 is 6. 9 plus 2 is 11. So by adding 2 to the inputs from here, now when I put these in here, the first step is going to be subtract 2. So watch what happens. G of 2 is the square root of 2 minus 2, which is the square root of 0, which is 0. G of 3 is the square root of 3 minus 2, which is the square root of 1, which is 1. G of 6 is the square root of 6 minus 2, which is the square root of 4, which is 2. And G of 11 is the square root of 11 minus 2, which is the square root of 9, which is 3. So I still got nice outputs, but I had to adjust my inputs to kind of compensate for the fact that we're going to subtract 2. Okay, let's see what this graph looks like. X is 2, y is 0, x is 3, y is 1, x is 6, y is 2, and x is 11. Let's see. It's right here. So we get this graph. Notice what the graph looks like. It shifted it 2 units to the right. So having a minus 2 in there shifted the graph 2 units to the right. And we'll talk more about that later. Let me ask you this. What's the domain of this? Well, the first x value is not 0 any longer. It's 2 going on up to infinity. And the range goes from what? 0 to infinity? It's supposed to be a bracket. I get sloppy there. Sorry. So the domain increased by 2, or the restrictions on it. Okay. Any questions about this? All righty. Let's take a look at, let's do this. It says, find the domain of each function. All right. So f of x equals the square root of x plus 6. And even though I'm on the graphing screen right now, we're not going to use the graphing screen at this point, but I don't want to switch back if I don't have to. All right. What do we know about the radicand? Can the radicand be negative? Can we take the square root of a negative number? This is where one of you chimes in with an answer. Can you take the square root of a negative number?
No.
Thank you, Jamie. All right. So that means this can't be negative. Okay. Could the radicand be 0? Can we take the square root of 0? Yes. Can we take the square root of a positive number? Yes. So that means that the radicand, the stuff inside the radical, has to be positive or equal to 0. So if we set the radicand greater than or equal to 0, that means it's either going to be positive or 0. It's not going to be negative. Well, guess what? There's your domain right there. So how do I solve that for x? I'm going to subtract 6 from both sides. So the domain of this function would be x is what? From -6 to infinity, greater than or equal to -6. So how did I get that? I took the radicand and made it greater than or equal to 0. And that led to the domain. So I could pick anything from -6 up, plug it in here, and I'd have a radicand that would be 0 or positive, and I can take the square root of that. But if I go below -6, then I'm going to get a negative number, and you can't take the square root of a negative number. All right. Next example. h of x equals the square root of 35 minus 5x. Question says, what is the domain? All right, I'm taking a square root, so the domain would be by taking the radicand and making it greater than or equal to 0. Solve it for x. Well, I'm going to subtract 35 from both sides. Negative 5x greater than or equal to negative 35. I'm going to divide by negative 5. What happens when you divide both sides of an inequality by a negative number? You change the direction of the inequality sign. So the domain is going to be x is less than or equal to 7. So that would be from negative infinity up to and including 7. Okay. So in this case, our domain is a whole bunch of negative numbers. Well, because we've got minus 5 times x, minus 5 times a negative would be a plus, a positive. Okay. But again, I took the radicand and said it's greater than or equal to 0. Okay. Let's do one more example of that. T of a equals the square root of 3a plus 17. What is the domain? Well, we take 3a plus 17 and make it greater than or equal to 0. Solve for a. Subtract 17 from both sides. 3a greater than or equal to negative 17. Divide by 3. A greater than or equal to negative 17 thirds. So your domain is negative 17 thirds to infinity. And there you have it. Any questions about that? All righty. We're going to take a break. That's going to be the end of 9.1 part 1. So I'll stop the recording.